Thank you for taking your time for my session. I'd like to talk about the TensorFlow Lite and how it can give a value for the mobile developers. I'm Kaz. I have been working at Google for the last 7 years. And the last 4 years, I have been working as a developer advocate for Google Cloud. Developer advocate is like an evangelist for developers. So I usually attending the events like this or meetups, talking about the technologies, especially on the machine learning or data processing technologies. So today, I'd like to discuss about these topics, why ML matters for the mobile devices, the smartphones or embedded systems. What is TensorFlow? And then I'd like to introduce TensorFlow Lite, which is a specialized version of TensorFlow for the mobile devices. And then I'd like to discuss how you can write your code to use TensorFlow Lite. And then I'd like to show some interesting use cases of TensorFlow Lite. So why ML, machine learning, matters for mobile device? I'd like to quickly discuss what is the meaning of the terms such as AI or ML or neural network. There's no clear scientific definition what is AI, but you can think it's a science of making things smart, like a smarter IT. So for example, in the traditional IT system, it's really hard to recognize an object in an image or the understanding what the people are talking by listening to the audio. So the techniques such as machine learning is used to realize the vision of the AI, making a smarter IT systems. And with machine learning, instead of using human programmers, you can use data to program your computer. So usually, when you are building the IT systems, you have to hire tens or hundreds of the programmers describing the program code, the rules, how the IT systems can process your data. But instead, with machine learning, you can use the data to let the computer finding what's the rules or patterns in the data to defining the logic of the IT system. And one of the machine learning algorithms is the neural networks. And at around 2012, we have been seeing a breakthrough in the neural network research. And that's the core of the today's AI booming by using the neural network for the image analytics or the voice recognition or natural language processing. And you can think neural network is just a function in a mathematics or just function in a programming. So it takes an input data, and then it does some calculation inside it and gets the output as a result. So many people, it's artificial intelligence, but for me, it's not real intelligence like humans' intelligence. Rather, it's just a function, or you can say it's an electronic calculator that takes the images or the audio or the natural language to do the smarter calculations on that. There's no consciousness or intelligence, real intelligence inside the neural network yet. So let's take a look at some interesting video that shows how neural network can learn patterns from your training data. So now this neural network is trying to capture certain patterns in the data set, which has the two groups of the spirals. One is the orange spiral, and another is the blue spiral. And as you can see, in the initial phase of the training of neural networks, it doesn't make any sense on the data. But if you keep trying the training, the neural network with your training data and spending much computing power, the computer gradually finds the patterns hidden inside the data, just like you are seeing right now. So after spending some time for the training, the computer finds certain patterns, like a spiral patterns or any other complex pattern you can see in real business data. So that sometimes the computer can find, can do the prediction or classification tasks as well as just like humans do. So this is how the neural network works. And if you have many layers of these neural networks, you can have the so-called deep neural networks that achieves much higher accuracy on image recognition or the voice recognition, translation, or natural language processing. For example, in this example, the neurons in the lower layers, actually this neural network design is called Inception version 3 neural networks that is developed by Google, and that has about 40 or 50 layers between the input data, images, and the output result. And if you take a look at the neurons in the lower layer, the neurons are trained to recognize very simple edges or patterns of the objects in the image. Neurons in the middle layer can recognize the eyes or nose of animals. If you go to the higher layer, the neurons are getting much smarter. For example, there are some neurons that can recognize dog snout or cat leg. And eventually, you would have a final neurons that can recognize that there is a laboratory retriever in the picture, or there's a tiger cat in the picture. So these neurons could be as smart as humans to recognize the objects in the images. So the mechanics of the neural network is very simple, just like as I shown on the video. But if you have the deeper layer of neural networks, very interesting thing is happening. And Google has been using these deep learning technologies for developing many production services, including Google Search, Android, and over 100 production projects in Google. For example, if you are using Google Photos smartphone application, you don't have to put any labels or folders for classifying your photographs taken by the smartphones. Instead, you can just use this Google Photos and enter some keywords such as the boats or beach or flower or car for searching any past images taken by smartphones. The email applications such as the Gmail or Inbox from Google now has the smart reply features that show some buttons at the bottom to reply to each email thread. So the neural network tries to understand what's the context of each email thread conversation to show the appropriate reply, like thank you so much, or no thank you, no thanks. And recently, we announced a new feature called Smart Compose, which allows you to get some suggestion on composing the email text on Gmail. That is all based on the neural network. Google Translate, 2 years ago, Google Translate introduced a neural machine translation model that has increased especially the fluency, the quality of the translated text significantly. So all of these, the mobile applications is getting benefits from the machine learning. And why machine learning can be important for the mobile phones and smartphones? Because you can think the machine learning as an extractor for the essence of your data. So for example, if you're taking a picture with your smartphones, easiest way is to send the whole images back to the cloud, where the cloud service does any smart analytics on the photos. But instead, if you can run the machine learning algorithms inside your smartphones or small devices, then you can extract some essence of data. For example, if you take an image, you can use the machine learning algorithms inside smartphones to recognize what's the object inside the photos, such as the flower, or the dog, or cat, or wedding party. So you can just send those labels, such as a cat or flower, to the server, instead of sending the raw data as is. So it can achieve like over 10 times or 100 times compression ratio compared with sending all the raw images to the server. Another example could be the motion detection. So the smartphones usually has the motion detectors, motion sensors inside it. And what if you want to create some applications that detect the certain motions from that sensor? For example, if you want to detect whether the users are sitting on a chair or walking in the street or maybe taking a taxi or taking a car by looking at the emotions detected by the sensor. Again, easiest way is to send all the raw data to the server where you can run the smart analytics on that. But instead, you could have a small machine learning algorithms running inside the device, the smartphones, so that you can extract the very important part of the data, motion data, and extracting the embeddings. Embeddings is the vector which represents the signature or the patterns of the data, and send the embeddings to the server. That also achieves the very high compression ratio, so that you can get many benefits by running the machine learning on the device. For example, you can get the lower latency, and you can also running the machine learning algorithms running on the mobile devices, even when you don't have any internet accessibility. And also, you don't have to send all the device to the server. Instead, you can access all the raw data from the mobile device and extract certain important patterns from that. And also, it's very power efficient. All data is accessible because your machine learning algorithm is running on your device. So we believe that the best way to get those benefits of the machine learning for the mobile developer is to use the TensorFlow. TensorFlow is the open source library for machine learning developed by Google. TensorFlow is the standard tool for developing any new AI or machine learning service inside Google. And TensorFlow has been developed by the Google Brain team and open sourced in November 2015. So now anyone can go to the tensorflow.org to download TensorFlow and try it with your own laptop or smartphone. And TensorFlow started as a deep learning framework, but now it's extending its scope to the wider machine learning areas. The traditional machine learning algorithms such as the random forest or the SVM or large-scale linear regression, we are trying to capture the many different machine learning use cases by using TensorFlow. Also, it's scalable and portable, so you can get started with TensorFlow by learning it on your laptop or mobile phone. But you may feel it's so slow to train your model with your laptop. So usually people would want to use GPU rather than CPU, so that you can get 10 times or 50 times faster training speed for training your deep learning model. But you don't have to, basically you don't have to change a majority of the TensorFlow code when you're moving your code from CPU or laptop to the GPU server. Or even if you want to train your model with 10 GPU servers or 100 GPU servers, basically you don't have to rewrite everything from scratch because TensorFlow is designed in a scalable way. And also we provide the cloud services to provide the fully managed TensorFlow runtime environment. So you can just upload your TensorFlow code to the cloud environment to have tens of GPUs training your model with your TensorFlow code. Also, once you have finished your training on the cloud, you can just copy the model of TensorFlow to the smaller devices such as Android, iOS, or Raspberry Pi. So it's portable. And with those benefits, the TensorFlow has become the most popular deep learning framework in the world. We got over 100,000 stars on the GitHub, and many enterprises, including the Uber, SAP, DeepMind, or what else, the Airbus, Twitter, they are all using TensorFlow for production development use cases. And now let's think about how you can use TensorFlow to develop your neural network for mobile devices and embedded systems. Because the TensorFlow itself is not specialized for the small devices, but the on-device machine learning has many challenges because you have small memories and you have to think about the battery consumption, and you can access the very small CPUs like an ARM processor. But neural network is big compared with the traditional machine learning algorithms. It's a downside of neural network deep learning. For example, the Inception version 2, version 3 model for the image recognition, that uses the 91 megabyte of the parameters. the values such as the weights and biases. And also, if you're using TensorFlow as is, the default binary size is something like 12 megabytes. But you don't want to have your mobile application users downloading 100 megabyte of the binaries and parameters just for using your smartphone application. So you have to think about how you can compress the models and binaries. So there has been many different techniques used for compressing the models and binaries for the mobile use cases, such as freezing graph, quantization, and selective registration. Freezing graph means you have to convert some of the values in the neural networks from variables to constants, because usually people don't train the model on the device. Instead, people are using the cloud services or on-premise devices, GPU servers for training the model, and then copy the model for the mobile devices for using that, the prediction or inference. So that means when you are using TensorFlow on mobile devices, you don't have to have the parameters as variables because they won't change anymore. The training is finished. So you can convert the variables to constants. That allows you to much faster learning of the parameters and much the compact format you can use for the holding the parameters. Another important technique is the quantization. Usually when you are using TensorFlow, the default the data type is the 32-bit floating point or FP32. That means you're holding all of the parameters with the 32-bit floating point values. But if you learn some basics about neural networks, actually the neural network doesn't require that kind of the high precision on holding those parameters, weights and biases. Because it tries to mimic the behavior of the human neurons that would be excited or not excited by taking any signals like lights or sounds or the smells. So usually, you don't have to have the really high precision on calculating the neural network training or the prediction. So for inference, many people are using the quantization that compresses the 32-bit float value into an 8-bit integer. That allows the hardware designers much easier to handle the calculation of the neural network. And TensorFlow provides the native data types on the many native operations that supports the quantized 8-bit integer. For example, data types, we provide the qint8, and also you can easily quantize or dequantize the values to the 8-bit integer, and also some operations suppose the quantized value, so you don't have to dequantize for calculations such as the matrix multiplication or convolution pooling activation. So the third technique you could use to compress your model, compress your machine learning the model, is the selective registration. That allows you to remove the unnecessary part of the TensorFlow binary for mobile use cases. Because, as I mentioned, many people don't do training on the mobile phones. The whole training part of the TensorFlow binary are not required for the mobile use cases. So by choosing the binaries, you can have the much smaller binaries. Yeah, you can compress the binary from 12 megabytes to 1.5 megabytes for inception registry, for instance. So those are all the tips and tricks you had to use, you had to think about when you were creating the machine learning applications on the mobile devices. But those techniques are not so easy to apply. So that's the reason why Google has started developing the TensorFlow Lite. That covers a majority of those techniques I have described automatically. So the mobile developers don't have to think about those complex things. TensorFlow Lite is a new version of the TensorFlow runtime as a lightweight machine learning library for mobile and embedded devices. So it provides the easier, faster, smaller way to run your TensorFlow model on your mobile device or embedded systems. So what you have to do is to train the ordinary TensorFlow model on cloud or on-premise devices, and then use a converter to output the trained model as a TensorFlow Lite format, TF Lite format. And then you can read the TF Lite format file into a mobile devices such as Android, iOS, or Linux, such as Raspberry Pi. For Android, the Android team has been working on defining an Android neural network API. That is a new API standardized for the Android devices. And the most important fact is that it provides the hardware acceleration layer or abstraction layer for the hardware accelerator for mobile devices. For example, the Qualcomm has been providing the hardware acceleration for TensorFlow for over 1 year. But if you want to use that Qualcomm hardware accelerator for TensorFlow, you had to download the SDK from Qualcomm and using some C++ code and build your own binary that only runs on the Qualcomm certain devices. That is not portable. So instead, by having the Android neural network API, developers don't have to think about the hardware-specific or the vendor-specific SDK or API. You can just write your code against the NN API so that should work fast on many different devices, such as Qualcomm devices or any other devices. And by combining the NN API with TensorFlow Lite, basically the TensorFlow users don't have to think about the existence of the NN API because TensorFlow Lite interpreter becomes a wrapper for the NN API. So you don't have to use the NN API directly by yourself. You can just write your own TensorFlow graph with the Python code, and then it can be converted to the TensorFlow Lite format, and that's it. That will be automatically running on the NN API. That will be using the hardware acceleration on each device. So let's take a look at what's inside the TensorFlow Lite. So as I mentioned, there will be a converter that will be converting the TensorFlow graph to the small TF Lite format that is based on the flat buffer. Flat buffer replaces the existing protocol buffer, which has been used as the standard format for the TensorFlow. Flat buffer provides a much smaller footprint for the mobile devices, and it's much faster to open it and load it on the mobile application. Also, we provide the interpreter for the TensorFlow Lite format and provide the operation kernels that maps to the device-specific instructions, such as Neon instruction on ARM. And also, we support the hardware accelerations, such as the GPU support or the DSP, digital signal processor support from the Qualcomm and other vendors. And also, the quantization is natively supported by TensorFlow Lite, so it's much easier to get the benefits of the quantization rather than applying the quantization techniques by yourself. So what's the result? The result is much faster and smaller machine learning code for your mobile application. For example, if you apply the quantization with TensorFlow Lite, then you can get about 3 times faster inference speed on mobile and Inception version 3. So that's the benefit you could get with the TensorFlow Lite. And also, as I mentioned, the model size is much smaller. It's 4 times smaller by using quantization, rather than using the original float 32-point values. Binary size gets much smaller as well. So core interpreter has only 75 kilobyte compared with the 1.1 megabyte for TensorFlow. That is the smallest binary we could get with the selective registration. But by using the TensorFlow Lite, you could get much smaller. And even if you use the already supported operations on the TensorFlow Lite, the binary set is still small. It's like a 400 kilobyte. And let me also briefly mention about what's the relationship between the TensorFlow Lite and MLKit. After this session, we will have another session about MLKit. And what's the difference between the TensorFlow Lite and MLKit? MLKit is a part of the Firebase offerings. So if you want to use the MLKit, you can go to the Firebase website, and then MLKit is provided as one of the SDKs we provide. And MLKit is designed for the Firebase programmers, Firebase developers. So while TensorFlow is designed for the machine learning experts and the machine learning users, MLKit is designed to be as easiest as possible to get started with the machine learning for the ordinary Firebase developers. So if you don't have any experience on machine learning, maybe MLKit is the easiest way to get started, because it provides the variety of the easy APIs for image recognition or OCR, face detection, landmark detection, or barcode scanning. So if you want to play with the machine learning features without any machine learning expertise, yes, you can start trying out MLKit first. But then you will find that for some use cases, the MLKit doesn't have any features to support that. For example, if you want to detect some motions from the motion sensors, like if you want to detect whether the mobile phone users are walking or running or driving a car or anything, the MLKit doesn't provide an API to detect that kind of the use case. In that case, you may want to try using the TensorFlow Lite. So TensorFlow Lite is supported as a custom models in MLKit. So if you want to train and customize your own ML models for each business use cases or requirements, then you can use TensorFlow Lite combined with MLKit, so that you can still use the MLKit SDK and APIs, but you can access the TensorFlow Lite customized ML models. So that was the relationship between the TF Lite and MLKit. And if you want to use TF Lite to customize or build your machine learning model from scratch, what kind of code you would write? Basically, as I mentioned, the starting point is to train your own model on the TensorFlow. So there's no difference between the ordinary TensorFlow model development. And then you can convert it to the TF Lite format. And if you need it, you have to implement your own operations. But I suppose the majority of the use cases doesn't require these customized operations. So let me talk about that. So once you have defined and trained your model on TensorFlow, you can use the converter like this. The converter provides a .convert function that takes the existing TensorFlow graph, the saved model, and then the output convert it and output to the .tf Lite format file. And then you can copy that .tf file to the mobile phones, mobile devices, or embedded systems. And I'd like to mention that MLKit supports the distribution of the .tf file to the mobile devices. So maybe easiest way is to have the .tf file embedded in your application, but another way is to use MLKit to dynamically distribute the TF file to the mobile devices. And once your mobile applications downloaded the TF file, then it can read the model file with the API called interpreter, and then it's ready to use. So you can just pass any input data to apply the inference or prediction with the model and get output. For example, if you get some sensor data from the motion detector, motion sensor, you can convert the sensor data into a vector and apply the prediction of the motions by using the model. And also, it's really easy to integrate with your Android app, you only have to specify the dependencies for the TensorFlow Lite library on the Gradle file. And as I mentioned, we also support the CocoaPod in iOS. So it's also easy to define the dependency on the TensorFlow Lite in your CocoaPod description. But there are some limitations and caveats when you're using TensorFlow Lite. For example, currently it's limited to the inference operations. As I mentioned, many people don't want to train the models on the mobile devices. Instead, they want to train the model on the cloud or on-premise GPU servers, then use the model for the inference or predictions using the model on the mobile devices. So that's the reason why we only support about 50 commonly used operations for the inferences. For example, MobileNet, Inception version 3, ResNet, SqueezeNet, DenseNet, these are all supported with the TensorFlow Lite for inference, not for the training. And we also provide a quantized version of those popular models. So you can choose to use the quantized versions to get the much faster inference speed on smaller footprint. And if you really want to define your operations for your applications, you can also customize your operations by writing a C++ code. And as I mentioned, the frozen graph depth, freezing graph is still the important practice. So you have to use the frozen graph depth when converting the existing graph to the TensorFlow Lite. And you have to be aware of the unsupported operators, as I mentioned. And also, we provide some visualizers or tools for debugging the TensorFlow Lite as a feature of the TensorBoard or TensorFlow Lite visualizer. Okay, so let's take a look at some interesting demonstrations that is built by the TensorFlow Lite.
We quantized MobileNet classifier on some common office items and converted it to TensorFlow Lite. Our demo app achieves good accuracy and performance on a mobile phone. It can even recognize the TensorFlow logo.
Yeah. Yep. And there's another demonstration.
For the first time, we're showing TensorFlow Lite on the Raspberry Pi. While the camera demo we showed on the mobile phones earlier works on the Raspberry Pi, we thought we'd like to build something that takes advantage of the Pi's strengths. Let's look at the hardware. First, we have the Raspberry Pi system board. One of the great things about the Raspberry Pi is that it can connect to other hardware easily. Here we have connected it to a motor controller board. In turn, this is connected to two servo motors that can vary the aim of the camera. With this hardware, we've built an object detector based on the open source TensorFlow object detection model. This model produces bounding boxes given an image. When the detector finds a target object, it tries to center it in the frame by moving the camera. This is like a little virtual camera person.
So it's tracking the position of the objects in the picture by using the servo. Sorry. So by using TensorFlow Lite, you can easily build.
We can also track more than one
like
object.
this.
Here, the control loop tries to keep both the apple and the water centered.
Then there's a camera.
Come take a look at our demo outside in the demo booth.
So the camera tries to move the servo to do the centering of the objects in the picture. So that was one of the demonstration. And at Google, we started to use the TensorFlow Lite for production development of the Google mobile applications, such as the portrait mode in the Android camera, or Google Assistant, or smart replay features and Wear OS. So TensorFlow Lite is also used by the production projects in the Google, so the quality and the features will be get much from now on. Lastly, I'd like to show some interesting real-world use cases of the mobile applications of TensorFlow. These applications are had not used TensorFlow Lite yet because these are all past use cases, and there were no TensorFlow Lite at that time. But that shows that may inspire you what kind of the applications you could build with the TensorFlow Lite or having the TensorFlow model running in your mobile applications. One use case is the Coca-Cola, the mobile phone applications. They have been using the smartphone applications for improving the user experience of the loyalty program. The thing is that you can take a picture of the serial number in the bottom of the bottle cap so that the consumers can use the applications to claiming for the award, like getting some ticket for some games or something. And they are using TensorFlow model and apply the many techniques I have explained, such as the quantization or the selective registration by themselves, because they didn't have a TensorFlow Lite at that time, to shrink the model into a very small size, like a few megabytes as the total size, so that it does the OCR for the caps in the bottle. And also there's another fun use cases of the TensorFlow that is called gymnastic exercise scorer. So how many people in this venue knows the radio exercise in Japan? No, nobody. I have to explain what is that. So in Japan, in every morning, like at 6:30 a.m. or something, the Natural Broadcasting Radio Network plays the same exercise music called the radio exercise. So the millions of people in Japan does the same exercise every day at exactly the same time, same time. And this application is designed to measure some score, how well you have done with the radio exercise. And they have developed their own version of the TensorFlow Lite because at that time, they didn't have any TensorFlow Lite. So this vendor has a really talented people to build their own TensorFlow Lite compiler, so that can compress the already TensorFlow model into a few megabytes of the very small model that captures the motions from the motion sensors and detect what kind of motions the player made. Let's take a look at the video. So let's take a look at the live demonstration of the exercise scorer. So can I switch to the... So Japanese people are doing this exact exercise every morning. And this was so embarrassing because... Am I doing right? And the TensorFlow model in the applications now measures all the motions. You can see I'm holding the smartphones in my hand. So just like that. So let's stop. Oh. And you can see the bar chart here. So now the TensorFlow model is trying to evaluate how well you have done with the exercise. And you can see the bar chart here. That is the evaluation by the TensorFlow model inside these applications. It's a real thing. Okay? So go back to the slide. Yeah, go to next slide. So the point is that the TensorFlow is already available for production for the mobile applications and embedded systems. So please take a look please go to the TensorFlow Lite website and try it by yourself. And thank you so much.